So, are we always going to be able to prove that triangles are congruent? Are we always going to have a postulate? Is it possible that we may not be able to prove it, or that we may not have enough information? Yeah, it is. It is possible. Here's a situation. I've got a single tick and a single tick. So I know that those two sides are congruent. Double tick and a double tick. I know that those two sides are congruent. I do not have any other markings, and I do not have any other information that's being given to me. The only thing I know is that I have two sets of sides congruent. I have this. That's all. But that's not a postulate. So I'm not able to prove that these triangles are congruent. Maybe they are. Maybe they're not. But we don't know. We cannot prove it. Okay? Because we would either need a third set of sides congruent, or we would need an angle between them to be able to prove one of our postulates. Okay, let's take a look at some examples. The examples that were on the notes. Example 1. Are these triangles congruent to each other? If so, by which postulate? Well, we have a pair of single marks, double marks, triple marks. They're tick marks, so they're all sides. So that means I do have the side, side, side postulate. And so I can say that triangle ABC, all right, notice I went from A to B to C. I want to try to go in that same corresponding order. What angle over here matches up with A? It's D. All right, notice how these are kind of like flip-flops of each other. They're reflections of each other. So A matches up with D, B matches up with E, and C matches up with F. And so that's why I went in that order there. You want to try to go in the same corresponding order. Okay. In problem 2, see what's in blue pen here? That was not marked originally. Okay, that was not marked originally. What that looked like originally was this. We just had these markings. Now, according to that, I can't prove anything yet, but anytime you have two triangles sharing that common point where you have vertical angles, basically opposite angles, anytime you see that X pattern, that means that you do have vertical angles. You can mark them automatically on your own, and they are always congruent. And so now I can look at my markings. I like to actually cover up one of my triangles. All right. I do have a side marking, then an angle marking, and then a side marking. That's what's happening here. I have a side, angle, side. It matches up over here, side, angle, side. So yes, those triangles are congruent by the postulate side, angle, side. And I can name them in the same corresponding order, VTX and NRX. All right, problem 3. So in blue pen, this was not originally marked. The only thing that I would have had marked would have been this angle and that side. Here, of course, if the left-hand side is a right angle, then the right-hand side is a right angle. So I would have an angle on a side there. But going back to right here, if two triangles share a common side, then that side is considered congruent to itself, and I can automatically mark it on my own. So I had that center line being shared. I can say, reflexive property. Let me mark it. Why did I use double marks? That's because I don't know if this line is the same length as this line. Okay? Therefore, I can't mark it with a single mark. Otherwise, I'd be trying to say that that's the same measure as this one. And that's not true. All right? That's why I have to use a double mark. All right? So then I look and I say, all right, I got a side here, skip. I got a side here, and an angle. SSA. That spells a bad word backwards. That can only be HL if I have a right angle, and I do. So that's why this one was HL.